Hello guys, welcome back to the Big Data course on Data Fanatics. So today we are going to talk about Hadoop. What is Hadoop and why do we need it? So without wasting time, let's get started. So Hadoop is an open source software framework for storing data and running applications on clusters of commodity hardware. Let's break this up and understand it part by part. Hadoop is an open source software. So this means that it's openly available. You can download it, use it, change its core code, do whatever you want with it. So it's a framework for storing data and running applications. Now this means that you can store your data on it and then run applications. Right now you might be thinking that this is exactly what we do on a local computer, right? We store data and then we run applications. So what's new over here? What's new in Hadoop? So this answer is answered by the commodity hardware. We run these applications on clusters of commodity hardware. Let's see what this commodity hardware is. Okay, this is what commodity hardware looks like. Now from outside, it just looks like a box with some compartments in it. But actually it is a computer. It's a whole computer. It contains all the processing cores, the RAM and the storage. So it's like a one package without any desktop. That's why it's very cheaper than the usual computers and widely available. You can build it yourself too or buy it ready-made. You can buy all the cores, the RAM and then integrate them together. Also, another advantage is that you can replace or change any part at any moment of time. Another thing we are talking is that they work in clusters. Now, this is how they work in real world, in huge clusters, in huge racks, and therefore they are used for huge amount of parallel computing. If we want to increase our parallel computing, then we just need to add another cluster of these commodity hardwares. Now, here we are not talking about few GBs of data. Here we are talking about like many GBs or maybe few TBs of data. So like that's huge amount of data and you can just keep on increasing it. There is no limit to the how much amount of data you can handle or the limit to commodity hardware. You just keep increasing the clusters, you just keep increasing the racks and you can increase the computing, increase the storage, whatever you want. So that's the advantage of commodity hardware here in Hadoop. Now let's get back to the point. It provides massive storage for any kind of data and enormous processing power. So we just saw that we just need to increase the and we can increase the storage and processing power, whatever. And another thing, important thing is that it can handle any kind of data. The data might be structured, unstructured, or semi-structured. It doesn't matter that, it's not important that the data should be in a table. It may be in some JSON format, semi-structured, or maybe a text file with no structure, just some random text. It can handle any type of data. And the ability to handle virtually limitless concurrent tasks. Now Hadoop has got huge amount of computing power. So with its yarn, the resource manager, it can handle like limitless concurrent jobs together. So that's the power of Hadoop over here. Let's see this with an example. Suppose a company needs to find out what customers think about it, or maybe why some people prefer other company goods over theirs. To solve this problem, now suppose the company takes tweets from the last week. Do you know that almost 500 million tweets are generated every day and about 4 billion in a week? So do you think that a normal computer can handle this? No, not a chance. Because it would take like days to get the results and maybe if your computer malfunctions, then you have to start again. So that's why we need Hadoop here. Now the plan of attack may be that the first we filter out all the tweets by the hashtags of the company and then apply some natural language processing technique to find out the emotions, like what the customers actually think about their product. So for this, we need Hadoop, the huge amount of parallel computing. Otherwise, we will get our results in days. And this brings to our final topic, the Hadoop ecosystem. So here we are going to talk about all these tools. Till now we have discussed that there's HDFS, YARN, MapReduce, but we do not know what actually happens. So let's see and discuss this ecosystem in detail. First comes the HDFS. Now this is at the base. This is where all the files are stored. It's called Hadoop Distributed File System. As you can see by the name, it's a file system where all the files are saved. Now, here in Hadoop Distributed File System, first of all, it's scalable storage. This means that if you need to increase the storage, you just need to add another cluster of commodity hardware and you can increase the storage. We saw that, right? It's a very simple process. And second thing, HDFS is also highly fault tolerant. Now, how does this happen? Whenever you store a file on HDFS, it replicates the file by 3 and stores it on different commodity hardwares. So now suppose one of your commodity hardware fails, then the whole process does not need to stop. It does not need to exit or like stop in between because the file is present at 2 other places. It can carry on, it can start its processing again on that file part from over there. So that's how it's fault tolerant. It's a great functionality. After HDFS comes Yarn. Now Yarn is like resource manager of Hadoop. It enables flexible scheduling. So it like manages all the resources that are present over all the commodity hardwares. It keeps a track of the current applications, the resources they are using currently. And also it decides how much resources does it need to give to a new application that's coming in, and everything related to resources is managed by Yarn. Next comes MapReduce. Now MapReduce is a data model. It simplifies parallel computing. Now there are many data models in Hadoop ecosystem, but this is one of the best ones and it's used widely. As the name suggests, it has two functions, map and reduce. So it maps the data values and then reduces them. We will talk in the next lecture what actually happens in MapReduce and Yarn and HDFS. Right now, it's just intro to these things. Upon this comes the Pig and Hive. Now, Pig is another way to query your database, and similarly Hive. Hive is completely like SQL. If you know SQL, then like Hive is going to be, it's like there's no difference between SQL and Hive. Just the difference is that in SQL, you query structured data, but here the data can be of any type. So this is the functionality of Hadoop, that you can handle any type of data. After Hive, then comes Spark. Now you can see that Spark can work on HDFS. It can also work on Yarn or Mesos. It's also another resource manager kind of thing. So Spark is majorly used to handle the streaming data or apply machine learning algorithms using the MLlib library that it has under it. So similarly, you can see a lot of tools over here, but on top of this, we have got this Apache Ambari that we saw last time. Now this Apache Ambari, it's like a web interface where you can see all the metrics that are controlled by Yarn, all the resources that are currently being used, everything. And the files, you've got a file view. We saw that there was a file view. You can see all the files interactively. You've got an interactive interface to write Pig and Hive queries. And you can also see if all your tools are working correctly from there. So in simple words, you can say that Apache Ambari is just like a user-friendly web interface where actually you can control, check, or see what's actually happening in your Hadoop ecosystem. That's all for today, guys. I hope you liked this video. Don't forget to like and subscribe my channel and press on the bell link icon to get all the new updates. And if you have any questions, then go ahead. Ask them in the comment section. I will clear them up. Thank you, guys. Hope to see you in the next lecture.